All right, welcome back. So we've dealt with bagging, we've dealt with random forests, and now we're gonna start with boosting. Yeah. So we're still in ensemble learning. Yeah, we're still trying to combine a set of classifiers to make one super classifier. Yeah. So quick recap of what bagging is. What you're gonna do in bagging? Well, you have a data set that is drawn from a distribution P that we don't know. This data set would give rise to a model that we call H. So H is your classifier derived from D. What we're gonna do is we're gonna sample with replacement. So we're gonna take point out of D and then put it back. Then take another point out of D and so on. And that creates n samples. Yeah? So these D1, D2, D3, these are going to be data set on which we're going to apply decision trees. Something I did not specify yet is that the DIs all have the same size as D. So if you would look at these DIs, for example, one extreme would be that you take a sample, you put it back, you take the same point, you put it back, you take the same point. Yeah? So D1 on one end of the spectrum could be just one point repeated all the time. On the other end of the spectrum, you could have a Dn that is basically the same as D. Yeah? But what we're basically trying to create is a number of data sets and then use the weak law of large numbers and the central limit theorem to calculate an average classifier. So to each of these D's, we're going to apply a training process. So these H1, Hn, they are trained. And then at the end, we're going to take the average classifier. And this is just a pure average. In random forest, what is important is that in terms of decision trees, you go all the way. So you're clearly overfitting. And then also important is that all the HIs are calculated in parallel. It's quite easy. Today you have many computers with multiple cores. And this is something you can easily do. So and the whole idea is that your expected classifier, or the sample mean, will converge to the true classifier, the expected classifier we have here, if n goes to infinity. So if we have a large enough experiment, this will work well. So we've seen that variant bagging is reducing variance. Because why? Well, because the variance of h bar, is equal to, or I would say, converges to the variance of h divided by n, and it's the division by n that will actually reduce your variance. Okay, let's now take a look at boosting. Boosting is different. It's still ensemble learning. We still go from a set of learners to a super learner. But one thing in boosting, for example, is that the trees you will build are going to be limited in depth. You're not going to go all the way as you do with random forest. That's basically to counter variance and overfitting. There's several boosting techniques. We'll discuss mainly two of them, which is add a boost. Add a boost is a classifier. And we'll discuss gradient boosting. Let me change this here. There's two examples. There is XG boost and there is light gradient boosting machine. That's Microsoft's. We will not cover light gradient boosting machine in this course, but we will cover gradient boosting and we will indicate what the difference is with XG boost. Basically, XG boost is gradient boosting on steroids. Yeah. XGBoost is also the go-to library for all the Kaggle competitions in recent years. It's very powerful. Okay, so what does boosting do? Well, in boosting you combine a set of weak classifiers, and weak means that they have a high bias. Weak classifiers, they are no better than, or barely better than a guess, or a coin toss. And we're going to combine them to make a strong learner. So here you have the HIs that are weak classifiers. They all have their specific error, and we're gonna, ensemble them to H of X, which is the strong classifier. Now the difference with bagging, that is that H of X is now sequentially constructed. Yeah? So you have several rounds, and in each round we'll ensemble the components of H of X. And the overall goal is to reduce the total error. Yeah? So let's take a look at the first one. We'll have add a boost. And we're going to do an exercise on add a boost, so that you understand how it works. So in add a boost, basically your H of X, and this is a classifier, is the sign of alpha 1H1 plus alpha 2H2 and so on. The HI here are your weak classifiers, and the alphas here, the alpha I, give you the voting power, or how important you are in this combined classifier. And of course, the higher your error, the lower your alpha, which is quite logical. Because if you have a high error, you want to give that classifier low voting power.